Hello students. Uh, in the last class we had seen how to formulate the SVM into optimization problem, and also we have seen some of the mathematical background for solving the optimization problem with equality and inequality constraints. Now let us solve this SVM optimization problem. So we need to minimize this quantity subjected to the constraints like this. This constraint came from here. So if you take minus on both sides, this can be written as 1 minus yi wxi plus b equal to 0. Now first you construct the Lagrangian equation taking objective function as well as constraints. Now differentiate this Lagrangian equation with respect to parameters w and b. Here the inequalities constraints are inequality, so we cannot differentiate with respect to alpha. So we shall get another set of constraints. So other set of constraints would be a Lagrangian multiplier multiplied by this constraints equal to 0. If you differentiate L with respect to W, then you will get W plus alpha I minus of yi xi equal to 0. So here you might be little confused how 1 by 2 x transpose x became W if it is differentiated with respect to W. So if you take W transpose W, you will get W1 square plus W2 square, because it is W1 W2 multiplied by a vector, here you will get W1 W2 multiplied by W1 W2. So if you multiply one row by one column, you will get this. Now if this quantity you differentiate with respect to W1, you will get 2 into W1. This will be 0. Similarly, if you differentiate this with respect to W2, you will get 2 W2. Now if you take 2 common, so you will get W1 W2, that is 2 into W vector. So 2 and half will be cancelled out and only W will be left out here. Okay, so try to solve it by yourself. So W is equal to this. Similarly, if you differentiate this with respect to B, so these all quantity will be 0. Only one product containing B will be remaining, so you will get summation of this quantity equal to 0. Now here you can see that you have many number of examples, equations you obtained, and solving here still complex because you have 3 variables, alpha, n number of alphas and n number of W and B. So what we shall do, we shall substitute value of W in this equation, and this also we shall substitute, and we shall try to get one simplified equation. So try to substitute and see. So you will get this one. So value of W and B substituted. So now there is no more W and B, only one type of variable alpha. So now it is easier to solve. Okay. And subject to alpha will be non-negative, and summation of alpha I y will be 0. Now you differentiate this quantity with respect to all the Lagrangian constants, because now it became equality constants, except this one anyway it is positive non-negative. So now we can differentiate this with respect to alpha and try to solve it. Now if you differentiate with respect to alpha 1, so you will get 1 minus alpha I part will go away, alpha j will be left out. You may be surprising how it became 1. So let us consider if you differentiate x1 plus x2 plus x3 with respect to x2, what would you get? So summation of xi. Summation of xi can be written as x1 plus x2 plus x3 if n is equal to 3. So only one term containing x2, remaining will be 0. That is why it is 1. Similarly, here you can see the multiplied by half also removed. Similarly, if you do summation of alpha I, alpha j, if you differentiate this with respect to alpha I, what would you get? So let us say we have alpha as alpha 1, alpha 2, alpha 3. Okay. So if you multiply all combination of I and j, I will vary from 1 to 3, j also will vary from 1 to 3. So you will get a combination like 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3. These many combination of I, j you will get. Okay. Now here so alpha, you will get alpha 1 into alpha 1, I is equal to 1 to 3, j is equal to 1 to 3. So once I is equal to 1, j is equal to 1, you will get alpha 1 into alpha 1 square. Plus 1, 2 and 2, 1 are same. 1 into 2 and 2 into 1. Similarly, 1, 3 and 3, 1 also will be same. Similarly, 2, 3 and 3, 2 also will be same. So alpha 1 into alpha 2 you will get 2 times. You will get 2 into alpha 1 into alpha 2. Now alpha 2 square. Again 2 times alpha 2 alpha 3. Alpha 3 square. And alpha 2 times alpha 1 alpha 3. So total 6 terms, unique term you will get. Now if you differentiate this quantity with respect to, let us say, alpha 1, what would you get? So this will be 2 into alpha 1, this will be 2 into alpha 2, this will be 2 into alpha 3, remaining will be 0. Similarly, if you differentiate with respect to w alpha 2, so this term will be 0, here you will get 2 alpha 1, here 2 alpha 2, here 2 alpha 3. So in every case you will get same quantity. So you will get 2 into alpha 1 plus alpha 2 plus alpha 3. So finally you will get 2 into summation of alpha j is equal to 1 to 3. So 2 alpha j you will get. So this 2 and this 1 by 2 will be removed. Remaining term will be as it is because there is no alpha here. Okay, so summation of alpha j, the remaining terms will be as it is. Once you have differentiated with respect to alpha 1, so I is equal to 1. So here in every place of I it will be 1. So y1 x1, and in place of j it will remain as j. Similarly, you differentiate with respect to alpha 2. So in place of I you will get 2, j will remain same. So this way you will get 3 equations. Try to simplify, take one other side. Now further you simplify it and try to convert it into matrix form. Okay, so remove all ij. So directly y into y transpose into x transpose into alpha vector is equal to 1. How do you get it? So let us little more knowledge. Yeah. Look at here. So let us say alpha is a column vector, x is a column vector, but each x is again a row vector, y is a column vector. Now if you multiply x transpose x, so 3 by 1 and 1 by 3, that is outer product. So you will get 3 by 3. Okay. Similarly, now look at here. If you have equation like this, okay, alpha j x1 xj, what would you get? So j will vary from 1 to 3. So alpha 1 x1 x1, alpha 2 x1 x2, alpha 3 x1. 1 will be remain as it is. Okay. Similarly, if you have same equation with x2, you will get like this, Now if you take alpha common, okay, these equations can be simplified as matrix. So matrix X, alpha would be here. So if you take first row, first column multiply, you will get first equation. Okay. Similarly, if you multiply second row and first column, you will get second equation and so on. So finally it is, and this came from here. So it will become x into x transpose into alpha. Similarly, if in place of x, here could be y, then it could be y into y transpose into alpha. Now if you use both x and y both, you take y part also, x part also, and again you simplify, so you will get both quantity, like x transpose x also you will get, and y into y transpose also you will get, into alpha is equal to 1. Now this we have to take back to the SVM what we have seen just now. Okay, here. So here this equation in matrix form we got from here. So having this matrix form, it is easy to solve. So from here you can get value of alpha. Once you get value of alpha, you have to substitute alpha here to get b. And once you get b, alpha and w, You substitute W here and get B. Having W and B both, our model is done. So the prediction class will be sine of this function fx. So this way we estimated alpha and W and B. Okay. Now you can see that SVM is binary, based on binary classes. Every time it classify two classes. So in case you have more than two classes, how do you do? So what would you do? Every time one of the class you take class 1 and remaining all class you use class 1. Like if you have C1, C2, C3. So in first iteration you use C1 and these two you put C2 star. Construct the model and get the equation. Again next time you get C2 as one class and C1, C3 as one class and get the model. In next iteration you get C3 as one class, C1, C2 as one class and get the model. So you will get, if you have k number of classes, so k, C2, these many number of combinations, you will get various model and combine, take the union of those models. That will be used further for prediction of the classes. So fine. The next topic is non-linear SVM. So far we discussed linear SVM, means the two class what can be separated with line. But now in the next video we are going to see how to construct a non-linear SVM model. That we shall see in the next class.